Hello, everyone. I think we're going to start now. Hi, so thanks for being here with us today. My name is Charles Reboul. I'm working as Innovation Counselor for InnovÉÉ, a non-for-profit organization that supports and funds collaborative research in electric and smart transportation. AVIN and InnovÉÉ are both supporting innovation in transportation. And we are partnering for about a year now to enable a better cooperation between Quebec and Ontario. So I'd like to thank AVIN teams for their work in this joint webinar and thank our speakers for being here as well. Tony Han from EdPower and Mahmoud Shirazi from Calogy Solution will go through their presentations, and you can type your questions in the chat box, and they'll be answered at the end of the session. So let's start the presentation now, and it's time for Mahmoud Shirazi, CEO from Calogy Solutions. Mahmoud, the floor is yours.
Thank you, Charles. Yes, hello everyone. This is Mahmoud Shirazi. I'm co-founder and CEO of Calogy Solutions. So I'm going to share my screen. Perfect. Do you see my screen now? Okay, great. So thanks again for joining this presentation. So I'm going to talk about our company, Calogy Solutions, who has developed a novel thermal management solution for electric vehicles. So a quick glance at Calogy. We are based in Sherbrooke, Quebec, Canada, obviously. We began our operations in September 2019. I was the employee number one. Today, we are a team of 10 employees, 9 engineers. We have 1 person who takes care of administrations. We have, on average, 5 interns per session. We work a lot with interns because we like them. They like us. They work once in Calogy, then they come back next time. What we are focusing is really a battery thermal management for electric transportations. So our journey began in September 2009, as I explained. So I left the university, started as employee number one. Then we started some operations, first partnership. We started R&D. We started the second employee in January 2022. Employees 2 and 3, they just added our team right at the moment where COVID hit us hard. So basically, we didn't see them for 2 months in person before actually. Before the COVID situation was a little bit better, because at the time we were at the university labs, they closed the labs. So, but we wanted to continue the work. So one of our guys, he actually suggested that we could use his garage. So we moved everything to his garage. We continued working, and we could continue the development. So as you see, we have really continued the long line of startups starting in a garage, and Calogy is after Apple, Google, and Amazon. We have tested we have equipped 2 vehicles with our product to now. There is an electric bus that's already being tested in Montreal. There is a truck that's also R&D truck that's being tested. We moved into our offices lately. And 21, we are now accelerating our commercialization, which is our main focus now. So what we have done, our business model is based on collaboration with partners. So basically, we work with partners to integrate our thermal management technology in their battery packs. So it's a very close interaction with them. We did the first one with a local partner here in Montreal. They integrated our thermal management in their battery pack, and it worked pretty well. Another big boost for us was in 2020, in which we were selected among the top 5 finalists for Impact Canada battery competition. So it helped us a lot because we received $700,000 to develop a battery pack based on our technology with our partners. And also, we have a chance to win a $1 million award in 3 or 4 months. We have been recently working a lot with South Korean companies. We like them a lot because they're very open to innovation. Very risk takers basically. We're working with we have discussed with big names, and we already have submitted a joint development project with a battery pack manufacturer in South Korea. So here you can see an image of our technology. So basically what we do, we have developed these thin sheets that are very, very high, they have very, very high thermal conductivity. So typically 20 times more than copper. The way they work is based on the concept of heat pipes. So basically liquid vapor phase change, we'll see in more detail later. This is the functioning basis principle of our TGPs. We call them TGP, by the way, thermal ground plane. And basically they can be used both for heating and cooling, both. So here I'll share with you a video on how our technology works. Do you hear the sound?
Oh, Mahmoud, we don't have it. We just have the picture.
Okay, sorry. So let me see if there is an option. Oh, doesn't matter, I can explain. So here you see an image of a vehicle, and just a sec, I'm going to. So here we see an image of a vehicle, a battery pack. So if you look at the battery pack, these are prismatic. They can be prismatic cells, or they can be cylindrical cells in basically in a bunch in a module. Our TGPs are these thin sheets that are put between the modules. They absorb the heat, they transfer it to this top part. This top part, the condenser side, is in contact with a liquid cold plate, or it can be with a air-cooled system. And the way it works, here we see a zoom picture of the cross section. So here, so that was an example of, this is an example of how a TGP basically can be in contact with a heat sink. As I explained, the method is basically based on liquid vapor phase change, and a thermal ground plane can transport the heat to the heat sink for the cooling. It can also be put together with a thermal switch, which is another technology that we have developed to basically open or close the thermal breach. Here you see the example of functionality of the switch. So basically, when the switch is closed, the thermal path is established, and basically the heat starts to dissipate from the system. But when the switch is open, much less heat is lost from the battery pack. So it's a technology that we have developed in winter conditions. It's a patent pending technology. Perfect. So yeah, as I explained, the basic of the technology is heat pipe. The values that we can bring to the customer, first of all, is decreasing the risk of thermal runaway. Thermal runaway is a very, very dangerous phenomenon, basically, that we want to avoid at any cost. Here you can see an example. Look at the Tesla here. Huge amounts of energy that are freed in a very, very short time. So it can be very dangerous. So basically, we decrease the risk by decreasing the overheating of the battery pack, and also allowing for the battery pack to be built in a hermetic enclosed fashion, which is important for applications like marine and aircraft, electric aircrafts. We can also help increase the battery range in especially in winter conditions, by keeping the battery pack in the optimal operating range. Another very important part is decreasing the cost of the battery packs. The battery packs are typically over-designed right now to account for the cell aging and cell degradation that happens over time. So our technology can decrease the cell aging by providing a uniform cell temperature, and that has a direct impact on the cost of the battery pack. So we have done some numbers, some estimations. We estimate our technology can increase by 2 years, and also decrease the cost by 5 to 10%. because we use less cells. Another very important value proposition is range anxiety. So especially in winter, it can help a lot to increase the driving range by consuming less energy for self-heating. This one we have tested, we have seen that here in Quebec. So that's very important. Also, this technology can enable fast charging. The fast charging is already used. I mean, people use fast charging with cold plates and liquid cooling systems. Our technology is actually more effective for heat transfer, so potentially can be more useful for that. And finally, TGPs are lightweight and are flexible, so they can really easily fit into the battery pack. So currently, we're working on it's a few months we have moved to our facility. We have been working hard to develop our first generation or our MVP, minimum viable product. That MVP is ready. Now we're going to a commercialization phase, which is a challenge in itself. As you've seen, the team is mostly composed of the engineers. Now this one is new because we're going to be working with business people. So it's a lot of learning curve for us. We are putting together also a small prototyping line. So it's a kind of semi-automatic prototyping line. We are trying to produce like 1,000 TGPs per year. That's our objective. 1,000 may seem a lot, but each vehicle typically needs 50 to 100 TGPs at the same amount of the same number of the cells. So that the number can increase pretty quickly. So we're talking about 10 to 15 vehicles. We're also expanding very quickly. We're hiring new talent almost every 2 months. We have purchased a lot of equipment, and finally we're going for the first time we're going to participate in the Battery Show US this year in 2 months. Thanks to Quebec and Canadian governments, basically, they give us space to showcase our technology. We have been doing a lot of business development, even though we don't have a dedicated for that. But that's been our jobs. The co-founders, my partner Luc Frichet and me. So we have been talking to South Korean companies, as I said. Again, thanks to a commercial trade mission organized by the federal government. So we've been talking to a few large South Korean companies. With 2, the discussions are very advanced. With 1, we submitted the project. We're working with an electric bus manufacturer, big name in Quebec, Project Arrow, which is a initiative started in Ontario, first 100% Canadian EV. With a few big names in electric aircraft, a lot of these traditional EV aircraft manufacturers are now they want to make their own electric planes. And battery thermal management is a very, very big issue. Stationary energy storage is another interesting market for us. We're working with a Quebec partner. And finally, in terms of basically a company that is basically based in Canada and Norway, and we're working with them for marine battery packs. Market for thermal management, I think we all have a sense that EV is the future of transportation. So the market is expanding very, very quickly. All the components of the battery pack, they follow the trend, and thermal management is not an exception. So you can see some numbers here. These, from experience, I can confirm that $700 to $800 per battery pack is the budget that people are comfortable with to pay for thermal management. Very important lesson I learned actually. Automotive market is a very, very cost-sensitive market. So if not the first, the second question is cost. So every innovation should have cost in mind. I mean, if you want to develop a new technology, you should be sure that you have to make sure that you can sell it with a acceptable price, because otherwise it won't take off. What we have done, the growth that we have had has been largely thanks to the opportunities that we have had through our network, in Canadian and Quebecois, Quebec, both. Quebec, we have InnovÉÉ, of course, that supports EV and innovation for electric transport. We have also Quebec Propulsion Quebec. That's another organization. We have EcoFuel. That's a basically a accelerator for Cleantech. So these they help us a lot. Also ASSET, which is our accelerator in Quebec, and also a lot of very good contacts from the federal and Quebec government. So very important for a startup to have good connection and good contact with these organizations. In terms of the challenges, I would say for us, because it's a B2B market and automotive market, finding the right door to knock on is very important. Finding the right person to sell the technology. So these connections and just getting them interested to the technology is extremely difficult. Also, another big challenge for a startup is the production volume. I mean, they expect hundreds of thousands of TGPs per month. So that's why that was one of the strategic reasons that we decided to focus on the commercial EV market, so buses, trucks, because the production volume is much less. So we're able actually to manage that production. Because in automotive market, we're talking about millions of units per month, which is impossible for a startup. Another important point is funding, networking, very important. I'm happy to say that there have been some very good support from the Quebec government and federal government, and I think it's essential if we want the startups to grow, and especially past this death valley, which is from the starting point up to starting the commercialization. In terms of the challenges, COVID of course was a big challenge at the time when it started, because we couldn't work together at the same location. It put everything on halt. Fortunately now things are much better, so things are getting back to normal. People are going back. A lot of developments and R&D projects are back on track. So this is very good news for us. Another big challenge is time to market. It's a very quick-paced market, so we really need to act fast. And for a startup, it's difficult because we don't have the resources that these giant companies have. So we really have to be efficient in terms of the priority in the activities. Credibility is another difficulty, basically. It's always difficult to build a credible story for people to believe in you. If the first customer gets on board, the rest are easy, but the first one usually is very challenging. And the rest of them, as I said before, just finding the right person to talk to and building up production capacity are other challenges. In terms of our mission, basically, as you can see here, we want to be partner. We want to be your partner to work with your companies and basically grow. So if you're looking for partners in Ontario, because Ontario is a very important province in terms of the automotive technology. In Quebec, we have automotive mostly in commercial vehicles, but in Ontario is passenger vehicles and a lot of infrastructure for battery and thermal management. So we're really interested to speak with you. If you think that you are interested, you have needs actually thermal management, or just you're curious to know what we're doing, please contact us. Please contact me. I'll put my email in the chat box, and we can discuss. So I would like to thank AVIN for this opportunity, and I would pass, I think, speech to Tony, and I'll be answering your questions towards the end.
Thank you very much, Mahmoud. It was a very interesting presentation. I'll ask now Dan Ruby from AVIN to bring us to the next step of the webinar. Ruby, that's here for you.
Thank you, Charles. I'm Dan Ruby, Sector Manager for AVIN at OCI. My role is to work with these innovative technology companies and connect them to the resources provided through the AVIN program, such as the regional technology development sites, academia, and industry partners. I also work with companies to guide them through the AVIN funding streams. We'll now move to our next speaker, Tony Han, the founder and CTO of electpower. I'd also like to remind the audience to please type in your questions as you listen to the presentation in the chat box, and we'll be addressing these questions at the end of the session. So Tony Han is the founder and chief technology officer of electpower. He has an extensive background in the automotive and technology industry across multiple continents, such as a research team leader and an entrepreneur. He is the owner of multiple electpower core patents and electric vehicle powertrains. Mr. Han was a Galbraith Scholar and has a Master's of Applied Science degree in Electrical Engineering and a Bachelor of Applied Science degree in Engineering Science from the University of Toronto. Please take it away, Tony.
Thank you, Dan, for the introduction. Can everybody see my slides?
Yes,
okay.
We're good.
Okay. Well, once again, thanks everyone for joining the webinar today. Welcome to electpower's presentation. My name is Tony Han. I'm the CTO and founder of electpower. electpower is a technology company based in Toronto, Ontario. We focus on developing next-generation electric vehicle technologies to help accelerate EV and autonomous vehicle adoption. Our company has a portfolio of over 50 patents and patent pending, and a growing team of 20. We also have a very strong research partnerships with research universities here in Canada, such as University of Toronto, University of Waterloo, and University of Alberta. The company has experienced strong growth over the last 5 years, and with very, very strong support from OCE, INSERC, and NRCan in building our research partnerships, as well as attracting OEM partners to help accelerate technology adoption. As of April 1st, 2021, so just a couple months ago, we have completed our name change from Havlar to electpower. This new name and image are part of our exciting next stage growth as an EV technology company and as an innovator. We currently have a contract with an OEM customer to deploy our technology in one of their best-selling commercial electric vehicles. And we're also looking forward to opportunities to work with other OEMs as well. Some of the highlights of the awards and industry recognitions we have won in the last few years includes, of course, the OCE AVIN Accelerator Program. And in addition to that, very recently, we have won the NRCan Breakthrough Energy Award. You know, it's always very exciting and very nice to receive a tweet from Mr. Bill Gates. We have also received several industry recognitions, including being the winner for Best Low Carbon Technology Solution for Logistic Companies at the Commercial Vehicle Cleantech Challenge in 2019. There are 35 companies. We're the only Canadian company who participated, and we won the challenge in Colorado, in Denver, Colorado. We're also one of the 50 Cleantech companies to watch, and also we're the finalists for Global Energy Game Changer Challenge for Shell and Enel. You know, here at electpower, we focus on providing technology solutions for the next generation electric vehicles. On the electric propulsion and low-cost fast charging side, we have a smart inverter technology that provides 800-volt drive, as well as onboard integrated low-cost fast charging. If you would like to know more about this technology, please feel free to reach out to me after the presentation. And on the autonomous and charging side, we have developed a very efficient and unique wireless charging technology that can handle a very wide range of operating conditions in the real world. And with OCE AVIN's support, we're able to deploy this technology in our OEM partners' vehicle. And I'm very excited to tell you more about it today. So on wireless charging has a wider range of applications such as phone chargers and other chargers. Here, we're specifically referring to charging for electric vehicle itself, so the bigger chargers that charge the car, not the small chargers that charges your phone inside the car. So the market for electric vehicle wireless charging is expected to grow 43% annually over the next few years by some very conservative estimates shown here from 2019. But some other estimates expect 10 times growth in the next few years. So there's a wide range. But we are fairly confident this is a market we'll see tremendous growth over the next few years. As we can see in this graph, the biggest portion of the growth is expected to happen in Europe for multiple reasons. But I think the potential for growth here in North America and Canada, I think is underestimated. I think it's also because due to recent shift in EV adoption, especially in the last couple of years. Of course, if there are local innovative companies like EdPower to help highlight our innovative solutions and attract global OEMs, the local market growth can be accelerated because OEMs, by working with us, can understand local markets and local innovations better. Wireless charging has lots of benefits. I think the first thing I want to get out of the way is that wireless charging and wire charging technology today are both over 90% efficient. So this myth about the wireless charging be significantly less efficient is really not there anymore. So today, both wireless charging and wire charging are almost equally efficient, both over 90%. Of course, wireless charging has some unique benefits. No touch, hands-free charging, having a very low profile and low maintenance because there's no moving things around, no moving parts. And such convenience and hassle-free charging allows for other opportunities for quick charge and usage in different scenarios. Previously, that would be too much hassle for wire charging. If you're going to top up your car for 5 minutes, 20 minutes, do you want to go to a charging station, plug in the nozzle and charge? With wireless charging, you park, charge, and then when you come back, you're ready to go. So this opens up a lot of opportunities to use wireless charging in different scenarios. And I think more importantly, we want to get this message across that wireless charging is a very critical piece of a charging infrastructure that would enable an electric and autonomous future. With the future already in sight, we can already see it. We need to have wireless charging infrastructures in place to allow that, because you are not just gonna stand there and charge a autonomous vehicle. And of course, with the ongoing pandemic and the booming e-commerce scene, the demand for no-touch autonomous technology is growing rapidly. And I think it will further highlight the benefit of wireless charging and potentially accelerate adoption timeline. So maybe we're not even looking at the next few years. This timeline can be moved forward significantly. And I think the key for everybody on this call, for ourselves, for all the stakeholders, infrastructure players, is to understand the technology, trying it out with pilots, so that we can be ready for this autonomous and electric future. I think it's very important to stress that all stakeholders needs to be ready for this electric and autonomous future, both the infrastructure side, the vehicle side, consumer side, and the business side as well. Here's our EdPower's wireless charging technology. The technology, just kind of a quick rundown, consists of a control box that takes power from the electric grid and consists of a receiver and transmitter. The receiver is mounted usually underneath the car, somewhere in the car, and is connected to the car battery. So how the technology works is that the control box can be one-to-one, can be one-to-many transmitters. The control box will take power from the wall, from the grid, and put that into the transmitter. It's a wire connected. This wire can be buried underground, can be over the ground, depends on the usage scenario. But the electricity essentially flows into transmitter, and transmitter contains a lot of something called leads wire or coils that change electrical energy into magnetic energy. And the magnetic energy is, once again, transferred over the air. So there's no physical contacts between the receiver and transmitter. Energy is transferred over air through magnetic field and received by the receiver. And the receiver converts magnetic energy into electrical energy again and charges the battery. So that's usually kind of in general on the highest level how the technology works. And of course, with EdPower's patented EQR multi-coil technology, we enable a very highly efficient and safe wireless power transfer with automatic magnetic field orientation. This concept of field orientation is very important because it is critical to address one of the key bottlenecks in deploying wireless charging technologies in the real world, which is called misalignment. And here I'll talk a little bit more about what misalignment is. The misalignment problem. Misalignment here is defined as the center-to-center offset between the transmitter and the receiver. So you have those two kind of rectangle pads, transmitter and receiver, and they both have a center. The center-to-center offset is defined as the misalignment. This can occur across vertical, lateral, longitudinal, and angular misalignment. Right? The efficiency of the wireless energy transfer highly depends on this misalignment, will continue to decrease rapidly as the lateral misalignment reach approximately 10 to 15 centimeters. The 10 to 15 centimeter, you can visualize this as your half of your tire width, the regular car tires. It's a half a tire width. If you park beyond kind of a half a tire width, you are charging at a very, very low efficiency. I can go to the next slide to show you what it is. But I just want to emphasize again, the misalignment is defined as center-to-center offset between the transmitter and the receiver. And the most critical offset is the lateral misalignment. So here on the left-hand side, you see the vehicle from the top. You have the receiver that's mounted on the vehicle. You have the transmitter on the ground. On the left-hand side, you have perfect alignment because the center-to-center of the transmitter and receiver is perfectly aligned. And this is when the condition that we all receive 90% efficient in charging. On the right-hand side, you have a situation where the car is parked slightly to the side. So there's a 15 centimeters, as you can see on the graph. There's a 15 centimeters of a misalignment between the receiver and transmitter. This is roughly about half tire width of a misalignment, so it's fairly small. And if that condition happens, the power transfer efficiency of the wireless charging becomes very, very low, and I can show you in a later graph. And one other point I want to make is that there are many different misalignment. It's important to talk about door-to-door misalignment, so this horizontal misalignment, because if it's in the direction of the vehicle driving, the vehicles can easily, let's say, relatively easily make adjustments. But with horizontal and the door-to-door misalignment, if you imagine you're parking a parking lot and try to park in the center of two lines on the ground, it is very difficult because then you have to do multiple reparking to get to the perfect spot, and you might never get there. I know I cannot, so it's a real challenge in this case. It is important to look at solutions for this because I know with me I cannot park so perfectly, and with real life situations, there's always going to be a misalignment. Even with sensors, it is very difficult to get within 10 centimeters, 15 centimeters of accuracy. And in looking for the solutions, it's also very important to put the constraints in place. I think we need to highlight the importance of or the benefit of wireless charging. Definitely no mechanical moving parts. We don't want anything that like a robotic arm moving things around. That could be a high maintenance piece of the charging system. We don't want anything on the ground that can trips or kind of does not work with different vehicle sizes. We want to keep it as much electrical as possible with no moving parts. So in coming up with a solution here at EdPower, we kind of going back to the previous topic I mentioned, we have this idea of automatic field orientation. Here, let me quickly explain what we are seeing here. What we are seeing here with the color graph is the strength of the magnetic field. So we talk about the energy being transferred from the ground, which is the transmitter pad, to the receiver, which is mounted in the car, through magnetic field over air, right? So the strength is the magnetic field. Red is stronger, and blue is very very low strength. On the left hand side, you have perfect alignment again. As you can see, field is perfectly centered around the receiver. However, if you have a misalignment situation, you can imagine that if the things are shifted to the left hand side, it's not going to be centered anymore because the receiver and the transmitter needs to be coupled. So which means that you are shooting a lot of magnetic field to your receiver, but it's not captured. You can view this as some of them being captured, some of them are not, and there's going to be a lot of efficiency drop if that's the situation. With our EQR multi-coil system, what we come up with is that this automatic magnetic field alignment technology, where on the right-hand side graph, you can see that the receiver is moved to the left 15 centimeters. It's moved to the left 15 centimeters. However, the magnetic field is still centered roughly around the center of the vehicle. And this is very, very important because most of the energy in this case will be captured by the receiver, and there's no leakage field kind of uncaptured flying around everywhere. So I just kind of want to take a pause here, make sure that everybody understands what I'm talking about here. So the strength is the color indicates the strength of the magnetic field, and with our technology, we have the ability to automatically shift the field distribution to have that most of the magnetic field still be captured by the receiver. As a result, the outcome is very staggering. So on the right-hand side, you can see in purple is our EdPower technology. The black is industry standard kind of benchmark that we use in this case. Yes, you have 90% efficiency for the benchmark, but as soon as you are starting to move away from the perfect center to center alignment, move to the left, move to the right a little bit, the efficiency starts to drop dramatically. We're looking at at 150 millimeters, which is 15 centimeters. The technology becomes unusable. You are essentially transferring less than a quarter of power into your receiver, and this causes a lot of problem. However, with our automatic magnetic field orientating technology, the EQR multi-coil technology, we're able to maintain a over 90% efficiency over a very wide range of operating points. This is essential. This is very essential for real-world applications because, as I just mentioned, to park within 10 centimeters or 15 centimeters, half a tire width, it's going to be very difficult. We cannot just sit around wait for a sensor to improve. Even with sensors today, it's not possible to park within such accuracy. The next question I think a lot of people will ask, kind of I briefly mentioned, is that what about safety? Magnetic fields, shooting magnetic field through air sounds like something very dangerous. This topic I want to briefly address before moving on is that there are very strict standards in both all the international standards, both IEC and SAE, governing the usage of wireless charging technology to make sure that any stray leakage magnetic field are below the well-established safety limits that we are kind of already familiar with other consumer devices. And there's always, of course, sensors to detect any potential abnormal operations to shut the system down. And in the particular case with the EdPower technology, here we have a side-by-side comparison of a non-EdPower benchmark technology on the left-hand side and EdPower technology on the right-hand side. As you can see, this safety limit of a magnetic field is much smaller on the EdPower side. Means that the field is much better contained. So the chances of this field kind of going beyond where the car is and kind of damaging or hurting anybody on the side is almost not there. It's potentially not there. It's even much smaller than the benchmark technologies that already meets the standards. Okay, so just want to repeat, on the left-hand side, you have the benchmark technology, existing wireless charging technology. On the right-hand side, you have EdPower technology, where both of them are misaligned 150 millimeters to the left. And you can see the dotted line encloses the safety magnetic field limits, and it is much smaller, much safer on the eLeapPower side because the field is more concentrated in transferring power. I'm coming to my last slide. This is a summary of the presentation I've made today. eLeapPower patented EQR multi-core technology enables very highly efficient and safe charging. It is very important to have this ability to orientate the magnetic field to be used in the real world when there's a wide range of misalignment. For eLeapPower, our next step will be we have a technology demonstration presentation in the next month, and we are currently working with our OEM partner on pilot programs. Once again, thanks everyone for your attention during the presentation today, and feel free to email me if you have any questions. Thank you.
Thank you, Tony, for that very interesting and enlightening presentation. First question from the audience is, what is the cost difference between wired and wireless charging infrastructures? And just to expand a little bit on that question, what do we need to do to get mass adoption of this interesting technology? And I'll start with Tony, and then I'll ask Mahmoud if he has anything to expand on the answer.
For sure. Wireless charging technology today is much more expensive than wire charging technology today for the same power kind of application for home mass applications. It's the 500,000 vehicle a year type of application. It's going to be much more expensive. The reason for that is that it requires use of magnets and lots of coils inside to transfer power. However, for certain applications, wireless charging technology can be on par in terms of cost, especially for higher power transfers, because other costs starts to add up. And I think the key thing for adopting wireless charging technology for especially wide adoption is that, as I mentioned at the beginning of the presentation, identify niche applications where the cost is an issue, but it brings cost savings in other area. Or you require wireless charging for certain constraints, for example, drones or certain autonomous vehicles driving in the autonomous warehouses or ports. You would need wireless charging regardless because that saves some of the people costs, right, for example. So just the technology hardware itself is more expensive, but the key is identify niche applications, niche vehicles to get this system started. And once you start hitting the volume and technology evolve, the cost will start coming down. But the key thing is get it started by identifying a key market and a niche vehicle type.
Great, thanks. Mahmoud, did you want to add to that answer at all?
I think I agree with Tony. I think from what I have seen up to now, cost is key. I mean, that's the most important question that people ask. And if you want a technology to be adopted, the cost should be acceptable. Especially, we should not forget that the battery market is actually the cost trend is downwards. So the prices each year are less than the previous year. So it means that we have to compete very hard with the existing technologies. We have to show the advantage of the new technologies so that we can justify the initial higher cost of the technology, adoption cost. And then, as Tony mentioned, later with mass production and increasing the volume production, we'll be able to compete with the price. So initially, I guess the price should be at least acceptable, but the technology should have really important advantages so that people have some incentive to adopt the technology. Otherwise, people will not do that. They'll just go with the solution that's already there.
Great, thanks. I'll pass it over to Charles for the next question.
Thanks, Dan. These questions, I have a question was more for Mahmoud. I was wondering, you mentioned you have several opportunities in the mobility applications, so plane, cars, but you mentioned also some stationary storage system. Can you bring more details about that? What solution will you bring on stationary applications, please?
Sure. Stationary applications is an interesting case because when we started our work, we thought that it's a simple case. Basically, you have this large container with a lot of lithium-ion batteries inside. You install it somewhere, it's stationary, doesn't move, there's no vibration. You can pretty much control the conditions in which the cells are inside the container. Solved problem. But in reality, we noticed that no, it's not a solved problem. In discussions with the companies who make these systems, we noticed that the lifetime is a very, very important issue for them, because here we're talking about gigawatts of battery. So very, very expensive systems. And the lifetime is extremely important, because if they can increase 10% of the lifetime, the saving on gigawatts of lithium-ion batteries is huge. And these guys have to guarantee usually these systems for 15 years. So these technologies, by the way, these energy battery systems are installed beside the renewable energy sources, so solar or wind, to basically smooth down the care energy production during the day. Otherwise, it will be very intermittent. But using these energy storage systems, we can have a more smooth curve in terms of the available energy. So again, we noticed that there is an interesting opportunity, and I think it's a nice example. The gap between sometimes the researchers, the engineers, and the reality of the market, because we thought it's easy, sure that it's been solved many years ago, but no, there is an opportunity there. So, and this is, by the way, it's a market that we have started to look at. We have discussing with partners, but we are really interested to push this further, because we see the value of our technology to increase the lifetime and the savings that we can bring to our customers.
I guess in a way you were unable to preserve the investment to guarantee the availability of this investment. Okay, cool. My next question is, maybe we'll start with you, Mahmoud, and then maybe Tony could add on. So you're both entrepreneurs, you both develop and run startups. Can you, Mahmoud, tell us how cooperation and collaborative works is important to support either the technology development, but also even your business model? So how do you cooperate with other organizations, universities, private partners? Can you give more details about that, please?
Sure. So in my experience, collaboration is key. Without collaboration, there is no technology, no company. Very, very important from all aspects. From technology development, you cannot develop a technology in vacuum. You need to work with people. You need to have access to equipment, especially in the beginning of a new technology. There is no, you don't have money, as simple as that. For which you need money, and you don't have money. So you need to work with people, convince them, encourage them, to work with you, and give you the opportunity. And later, this continues, because you need to convince the investors. Then after that, you need to convince the customers and the collaborators. In all of that, the whole ecosystem should be involved, because we humans are social animals. So we look at each other, basically. We get a lot of encouragement and courage from seeing an approval from others. I've seen investment, if there is one investor that jumps on board, the others are much more comfortable. For customers, the same thing. First question they ask, has anyone else used this one or not? If they see that it's been used by someone, people have paid for it, they say, okay, yeah, it should be something interesting. So for that to happen, we work a lot with our ecosystem around us. So we work with InnovÉÉ, we work with Propulsion Quebec. All of these organizations can do nice introductions. That also helps a lot. Investors, the same. Our investors, they try to help because they have invested in the company, so it makes sense for them that the company succeeds. And also the research world. So universities, we support, we actually fund research projects in Sherbrooke University, also in other universities in Quebec. We work a lot with the professors, because this is a market that's actually very, very advanced. So if we want to be able to compete with big players in Europe, in South Korea, in the US, we need to in R&D. So in Canada, we're lucky to have this strong R&D environment, but we should work hard to turn that into actually products that people would be ready to pay for. so that the whole ecosystem can function. So, R&D, development, selling the product, bringing back the money to R&D, and, creating wealth. In all of that, I think collaboration is key.
Okay, thanks. So that's a way to build trust and confidence from external stakeholders. All right, thanks. Tony, do you have anything to add on that?
Yeah, just maybe a couple of points. I think Mahmoud covered lots of points already in this case. Same for us. We work with all the universities and working with customers and working with other collaborators. We have collaborators for this OC AVIN program as well. There are two things I want to add on. I think it's very important. The first one is that startups and entrepreneurs always worry about competitions. Is somebody gonna steal my technology? No, the way I look at it is that in this electrification kind of age, everybody is your friend. Everybody is moving towards the same common goal. We want to accelerate EV adoption. So don't worry about that. Work with everybody you can. So that's the first point. The second point is that of course, with lots of collaborators, everybody is working towards their common goals. So one word of caution for other entrepreneurs is that just be very clear, define of what you want to achieve in this, and so that your goal it doesn't get lost or mixed in terms of the overall project.
All right, thanks a lot, Tony. It's very clear, and I totally agree with your very first point. I think that's really important. You don't have competition; you have partners. You're right. Danny, any other questions from your side?
Sure. Let me address the last one from the audience and then add on to it. So I know, Tony, you addressed this in your presentation, but just specifically, do we have to worry about strong field exposure from wireless charging? And then just to pick up on the conversation that we were having between, Mahmoud's talked about collaboration being very important. Maybe just a little bit on what are some of the benefits that you found being a Canadian startup, and maybe some ideas on how we can encourage that collaboration between Ontario and Quebec. So I'll start with Tony.
Sounds good. Thank you, Dan. The first point about whether people need to worry about strong magnetic field exposures when they stay in the car, definitely not an issue. When you are enclosed by a metal box, which is the car body, you are completely safe. Just think about those Tesla cages. You're completely safe. You're not exposed to the magnetic field at all. And usually, wireless charging systems they're building field shielding devices underneath as well, underneath the car, so the field doesn't go to you. There's a slight different question of leakage field and field that kind of goes beyond the car. Any wireless charging product goes out there needs to meet strict standards, so it's completely safe for people to stand beside the car while the car is being charged. And I don't think there's any concerns need to have for that. The particular technology we have here is just make it safer because the less strict field, the entire field content is smaller. I also want to quickly answer the question that in terms of advantage being a Canadian startup. One thing Mahmoud already mentioned in terms of the very strong support from the local innovation hubs and funding agencies, such as OC AVIN and InnovÉÉ in this case. I think it's very strong, very important to have companies like us in their early stages being supported by the local innovators hubs, because they understand where we come from, the roots, and the why we are working on the technology. Because sometimes you spend too much time fundraising, you don't have enough time to develop the technology. And if you have local support right away, you can get your heads down, move forward with technology. I think in that particular case, we have some advantage over other kind of startups in other jurisdictions, because there's very strong funding and research support network here locally. The other benefit I also want to mention is that we have Canada is great. Being a Canadian, I'm very proud being Canadian as well. There's a huge potential for the market here. It's a very big country here. A lot of companies are also interested in coming here. Do something with the local market. And being a Canadian company, you at a very early stage, you don't have to compete or worry about competing 5 years down the road for the bigger American companies, for example. You can focus on what you do, and then when the company comes locally, they want to speak with you. OC AVIN has been great helping us connected to different car manufacturers coming through the visiting, and we get to meet a lot of them. So I found that being very helpful, being a Canadian company in Ontario, of course, as well.
Did you want to add to that, Mahmoud?
Yes, yes. I was thinking from my experience, there are some advantages and some challenges at the same time. The advantages, I think Tony mentioned that well. It is at the same time to have access to this large infrastructure, R&D infrastructure. It is great to have access to public funding, which is, for the US companies, US startups, from what I have seen, is kind of non-existent. Some very limited funds, but very, very hard to get. A lot of competition. However, in the US, what's different is that private money is very, very available. So even for starting the company, you can easily go get a few $1 million and start your work. So again, the question of time, the time that we spent here in Canada to raise money, maybe $500K, is comparable to the time that, in the US, probably the same time you can raise $5 million. So that money can actually, can in reality, accelerate a lot your development. At the same time, well, the costs are higher in the US. The competition is more fierce in the beginning. So in Canada, we have this kind of cushion, basically, to give us some time to develop the technology without being worried that, we're going to die. We're going to be, a new technology will come. We're going to be dead in a few months. So that's an advantage. I think another advantage is actually the talent that we have access to. And the competition is not as crazy as the US. So the guys, especially, I'm sure Tony is living the same situation, but the guys that we have, they have, opportunities in 5 other big names right now in the EV market. The number of specialists in the EV market, engineers, is very, very limited in the entire Canada, I would say. So the talent is very important. And the advantage that we have in Canada is that the competition is much less compared with US. Still now is very competitive, but still much less compared with the US. So it gives us, again, a chance to keep these talents and develop the company.
Thanks, Mahmoud. Unfortunately, that's all the time we have for today's webinar. So on behalf of the AVIN team here at OCI, I'd like to thank the audience and all the participants for joining us here today. I'd like to thank InnovÉÉ and Charles Rebou and the entire team for partnering with us on this event. I'd like to thank the speakers, Tony Han from EdPower and Mahmoud Shiraz from Ecology Solutions, for their very enlightening presentations here today. And finally, I'd like to thank the OCI marketing and communications team for all their support on today's webinar. That's all for today. We hope to see you all again. Please stay safe, stay healthy, and take care.
Thank you.
Thank you
so much. Thank you so much, Dan.